Everything you see, every galaxy, every star, every atom in your body, once fit inside a space smaller than a single proton. And then, in less than 1 second, it exploded into everything that exists. This is not a theory. This is what the evidence tells us happened. The question is, what actually went down in that first second? Before the Big Bang, there was no space, no time, no darkness, because darkness requires space to exist in. Physics as we know it completely breaks down at this point. Even the word before stops making sense because time itself didn't exist yet. Stephen Hawking described it like this: asking what came before the Big Bang is like asking what's south of the South Pole. The question has no answer, not because we don't know, but because the question itself is wrong. What we do know is this: at some point, something happened, and in the first fraction of a second after that, the universe went through the most violent, most dramatic transformation in all of history. At t equals 0, the moment of the Big Bang, all the energy that would ever exist in the universe was compressed into a single point. Physicists call this the singularity. The temperature was 10 to the power of 32 degrees Kelvin. To put that in perspective, the center of our sun burns at 15 million degrees. The singularity was billions of times hotter than that. At this density, at this temperature, the four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces, were all merged into one single unified force. Physics, as we understand it, didn't exist yet. And then, it began. The first era of the universe lasted 10 to the minus 43 seconds. This is called the Planck epoch, named after physicist Max Planck. It is the smallest unit of time that physics can describe. During this moment, and we're talking about a fraction of a second so small it doesn't even have a name in everyday language, space and time themselves were unstable. They weren't smooth like we experience them, they were a boiling, chaotic foam at the quantum level. We have no equations that can describe what happened here. Our best theories, including Einstein's general relativity, completely break down. This is the edge of human knowledge. Beyond this point, we are in the dark. At 10 to the minus 36 seconds after the Big Bang, something extraordinary happened. The universe entered a phase called cosmic inflation. In an almost incomprehensibly short period of time, space itself expanded exponentially, faster than the speed of light. And no, that doesn't violate Einstein's rules, because it wasn't matter moving through space. It was space itself that was stretching. To give you a sense of scale, a region the size of a proton expanded to roughly the size of a grapefruit. That sounds small, but the expansion factor was 10 to the power of 26. If you scaled that up to human proportions, it would be like expanding a single atom to a sphere larger than the observable universe. This happened in a fraction of a fraction of a fraction of a second, and it set the stage for everything that came after. As the universe cooled from its initial fireball, something remarkable began to happen. Energy started converting into matter. The first particles to appear were quarks, the fundamental building blocks of protons and neutrons. But here's the thing: for every particle of matter that formed, an equal particle of antimatter formed alongside it. And when matter meets antimatter, they annihilate each other in a burst of pure energy. By all rights, the universe should have ended here. Matter and antimatter should have destroyed each other completely, leaving nothing but light. But something was slightly off. For every billion antimatter particles, there were 1,000,000,001 matter particles. Just one extra. That tiny, seemingly insignificant imbalance, physicists call it baryogenesis, is the reason you exist. The reason anything exists. The antimatter annihilated. That one extra particle survived. Multiply that across the entire early universe, and you get every atom that has ever existed. 1 second after the Big Bang, the universe had cooled enough for protons and neutrons to form from quarks. The temperature was now only 10 billion degrees. By 10 seconds in, the universe was a dense, hot plasma, a soup of protons, neutrons, and electrons, all moving too fast to bind together. Then, at around 3 minutes after the Big Bang, something critical happened. The temperature dropped enough for nuclear fusion to begin. Protons and neutrons started sticking together, forming the first atomic nuclei, hydrogen and small amounts of helium and lithium. In just 17 minutes, this process, called Big Bang nucleosynthesis, was essentially complete. The ratio it produced, roughly 75% hydrogen, 25% helium, with trace amounts of everything else. Look at those numbers. Then look at the composition of our Sun today. 73% hydrogen, 25% helium. The Sun is burning the exact fuel that was forged in the first 3 minutes of the universe's existence. For the first 380,000 years of the universe's existence, there was no light. Not darkness, because darkness implies the absence of something. The universe was simply opaque, a dense plasma so thick that photons couldn't travel more than a short distance before being absorbed. Then, at 380,000 years, the universe cooled to around 3,000 degrees. At this temperature, electrons slowed down enough to be captured by atomic nuclei. Suddenly, the fog cleared. Light traveled freely for the first time. The universe became transparent. That first light still exists today. We call it the cosmic microwave background, the CMB. It fills the entire universe, and we can detect it with radio telescopes. The static you used to see on old analog televisions? About 1% of that was CMB radiation. You were literally watching the afterglow of the Big Bang. After the CMB, the universe entered what astronomers call the cosmic dark ages. For the next several 100 million years, there were no stars, no galaxies, no light sources of any kind. Just vast clouds of hydrogen slowly drifting through expanding space. But gravity never rests. Slowly, imperceptibly, these clouds began to collapse under their own weight. As they compressed, they heated up, and at a critical point, when the core temperature reached 10 million degrees, nuclear fusion ignited. The first star was born. We don't know exactly when this happened. Our best estimate is somewhere between 100 and 200 million years after the Big Bang. We've never directly observed these first stars. They burned so hot and so bright that they lived and died quickly, long before any telescope existed. But the James Webb Space Telescope is now pushing the boundary. In 2022 and 2023, it captured galaxies from just 300 to 400 million years after the Big Bang, the oldest structures we have ever directly observed. You might be asking, how do we actually know any of this? We weren't there. We have no recording. The answer is convergent evidence from multiple independent fields. The cosmic microwave background, that ancient light from 380,000 years after the Big Bang, matches our predictions with extraordinary precision. The ratio of hydrogen to helium in the universe, 75 to 25, is exactly what Big Bang nucleosynthesis predicts. The expansion of the universe, confirmed by measuring the redshift of galaxies, points directly back to a single origin point. And at CERN's Large Hadron Collider, physicists recreate conditions similar to the very early universe, smashing particles together at nearly the speed of light to study what matter was like in the first microseconds of existence. None of this is speculation. It is the most tested, most verified model in the history of science. But for everything we know, there is more that we don't. What caused the Big Bang in the first place? We don't know. What existed before T equals 0? We don't know. Why was there slightly more matter than antimatter? We don't know. What is dark energy, the force that's accelerating the expansion of the universe right now? We don't know. The universe is approximately 13.8 billion years old. Modern science has been studying it seriously for perhaps 100 years. We are infants trying to understand something ancient beyond imagination. But here is what we do know. In the first second after the Big Bang, the universe went from nothing to everything. From a single point of infinite density to a cosmos of hydrogen and helium. Quantum fields and fundamental forces with all the information needed to eventually produce stars, planets, oceans, and a species curious enough to look back and ask, how did this all begin? You are the universe trying to understand itself, and that might be the most remarkable thing of all.